And you didn't sign out. You're going to do anything else stupid. Okay. Name on the list. Okay, that's the first thing the internet heard. Fantastic. So 4.3, we're going to start with increasing and decreasing functions. All right. If you're given a picture of a function, a graph, can you tell me where that function is increasing? Okay, on what interval? So this is something to be asked. On what intervals is that function increasing?
-3.
No.
0.
Nope. You see the arrow? What does that mean?
So infinity to negative infinity.
There you go. Okay, so we have to be very careful to include all of the possibilities, because that does continue for all eternity and time. Even though we can't see it, we assume it.
Is it like a hard 3 that's going to be a bracket or is it
Okay, what is happening at 3? The what?
The level's off.
Yeah, what's that called in calculus? Okay, there is a sign change around 3, or at 3. We have a slope of 0.
Yeah, well, 4 is all
Right? Is that increasing or decreasing at that point? No. So it is an open interval. Okay. It's a good question. Okay, where are we decreasing? This way, right?
Yeah.
3 to infinity. So up to the right is increasing, down to the right is decreasing. Yeah? Okay. How do you figure that out with an algebraic function? How do you calculate it algebraically?
No idea.
I have no clue.
Well, think calculus. What can tell you about the slope here? Yeah, so how do we figure that out in calculus? Duh. Duh.
You do the derivative?
Yeah. The derivative is positive for an increasing function. So it's still a sign analysis problem. So we've already done all the work derivative to do this. Okay? We're having issues today.
We're having
The derivative here is
negative.
negative.
Hey, he's one of the most famous people in the world.
I am not famous.
Yeah, I don't know. Kevin's desk, and I haven't slept with that.
I only post videos of myself on YouTube. That does not make me famous.
There's plenty of people that do that and make them
A
famous.
narcissist.
We should share this with
I think this is one of the worst videos you've ever
So here's one way that we can ask that question.
What does that say?
Strictly increasing.
So all
So it's only.
Yeah, so only increasing, right? Good way to put it. So how do we show that algebraically? Okay.
Yeah, chain good there.
No.
No, that's related rate.
We're all like, nope.
This is more simple than that. Okay, so Like with a root, we rewrite it, correct?
Yes.
And just do the power rule. Would you do the power rule for me?
Yeah. So, what's the derivative? 3.5 down, and subtract 1 from the exponent. Okay, I think we're having some mass remembering now.
Yes.
What's that purple drawing on the board?
Okay, moving on. Again, my advice is to always rewrite these. Okay, so if we are asked, so can this ever equal 0?
Well,
No, right? No. So there is no sign change. Right? And then what do you always know that comes out of roots? In real number calculus? Positives only, right? This only outputs positives, so and you can abbreviate like that if you want. So that always equals a positive, right? F prime, let's be specific here. And you know what this means, correct?
I remember seeing it. I cannot recall it.
That means that there's an implication that implies. So because F prime is always positive, F is strictly increasing. That's what that says. Or F prime is always positive, therefore F is strictly increasing. All right, so that's one way to show something is increasing. It's still using the derivative, right? Let's try one more. One more?
Yeah. Let's do one more.
There's no pass. We don't leave the room. No. The pass is my thing on it. ID.
Yeah, where'd you pass
I don't know where it is. Besides that, so we had a big conversation about this yesterday as a staff. You guys need to sign out.
Okay.
Because I haven't been following that, so let's just make sure. Okay. So, all right.
So we can't leave.
Oh, you can leave if you want.
Oh, yeah.
I just suggest you don't.
Do we have to pay you with fake money to leave now?
Fake money doesn't do anything for my wallet, so no.
I'll bring you in 5 million in an offer. I'll flip you.
What?
A quarter's not quite enough to pay for my retirement.
What about dollars? I think so.
It's a much larger number than that. Okay, what does this mean?
I have no clue.
It's a word your book uses.
Oh, that's great.
I don't remember seeing it on the AP exam.
What does it mean? Increasing or decreasing?
Always.
So you're basically showing where this function's increasing or decreasing.
Or.
So you just do what?
You can't increase and decrease. Can anybody tell me why?
Because it just works.
It doesn't work like that.
Why not? Right, exactly. You can't increase and decrease. It's not physically possible. You have to increase or decrease. They have to be separate items. Okay? Be specific with your language. Another lesson right there. Okay, how do we figure this out? Brandon,
Yes.
first step. Okay, what is it? All right? Set it.
Set the derivative
Thank you.
equal to 0.
Anybody disagree so far? I'm just writing out what you're saying. Good? Okay, what's next?
He's being sarcastic and being bad. Just ignore him. She's a bully.
What do we analyze?
Oh,
Yeah, I've heard it. I'll combine a lot of what you're saying. Analyze the derivative at 0 and 2.
Yes.
That's a 0. Okay, what are the signs?
negative.
You don't.
Right? Yes?
Yeah.
Okay.
So it's decreasing.
So F is decreasing. On what interval?
Wait, is it negative infinity to 1? It's so the teacher becomes a master.
There's no domain restriction. So you have to go back to the negative infinity.
How do you know it doesn't change direction at the same time?
Because that's what this tells us. This tells us, first of all, the algebra says there's only one sign change. Secondly, what shape is that? Right. Come on, If there was more than one sign change, you would have multiple critical values. You put them here, and you test inside each one. Where's that increasing?
From 1 to infinity.
Good job.
And beyond.
Good job, Kellen.
2 infinity. And beyond.
Thanks, Buzz. Okay.
We're all coming up with one Toy Story.
Okay, can you tell me where there's a minimum or maximum there?
1.
Which one is it?
There's an absolute minimum at 1.
Max at 1.
No, he said absolute. That's why I shook my head.
It's just.
Yeah, but it's a
Open
minimum.
up.
No, it's minimum.
It's a local.
No, that's you just did that. It's a positive x squared.
Is it a local? What is it? Why is it a local?
It opens up.
It is a min.
Okay, we're debating min or max.
It's a min, brother.
It's a
It
min.
goes down.
Yeah, it's a
It's a min. It's a local
Stupid.
min, not
Yeah, it's a
a
min.
Yeah.
It's a minimum
It's a minimum.
because,
What was I saying?
You said it absolute.
He said absolute.
is this throwing you off? Should I have done this?
Yeah. It's a y, not a v.
If only the YouTubers could see us now. Moving on. Okay, here's the
She
mean
got
of
face
today. The mean value theorem. I told you I was going to be mean to you.
Yeah.
Oh, that's hilarious.
Ba-ba. Okay. We've done the intermediate value theorem already. Okay. We have the mean value theorem. We will have an average value theorem. Okay, and then we'll have the fundamental theorem of calculus. We have 4 big theorems this year, so this is the second one. All right. If I asked you to calculate a mean of a set of numbers, what am I asking you to do? Find the average, right? So this is a theorem that deals with average, rate of change. Okay. We know the slope formula, right? So we are at, this is the theorem that deals with where the average rate of change equals instantaneous. Okay. Let's see.
average equals instantaneous?
This is the reason a cop can pull you over if they're timing you. I've told you that story, right? This is the theorem that they use to justify that. If a cop times you going 90 miles an hour on average, your driving is continuous, they can prove that you have an instantaneous rate of change of 90 miles an hour. Therefore, ticket.
So if like you can
Teenage drivers. Number one cause of death, isn't it?
Me.
if you're going like 90 at one point and then like 70 at another point at the same time.
Because this is what matters.
Yeah, but you're going 90 traffic like 70.
Then your average would be like 72 and a half.
See, then you're not going to say
Well, then your average would show up as 72 and a half, and you get a ticket because they couldn't show your instantaneous rate of change. It's on the speed limit!
No, they couldn't.
Thank you very much. All they care, all not Utah. All right, so.
While trying to win that use this theory.
Algebraical. Slope formula, right, for average rate of change?
Oh, yeah.
Yes? How do we calculate instantaneous rate of change? Yeah, the derivative. That's the algebraic version. Here's the graphical version. Okay, so the average rate of change from A to B is the slope of that secant line, right? From the instantaneous rate of change at some point, those will be parallel lines.
So it's saying that like your average rate of change at one point that average was instantaneous?
Yeah. So algebraically, you have your formulas that equal each other. Graphically, the lines are parallel, and the line is parallel to the secant line, right? The slopes are the same.
And that's just the point we're trying to find in this?
Yeah, so your goal would be to find where that actually happens.
Wow.
Okay. Or sometimes all you have to say is that it does happen. So I'll give you the conditions there. In order for this to be valid, continuous,
It must be.
so this involves a derivative, correct? So the function has to be differentiable. So if those conditions are not met, we cannot apply the mean value theorem. This shows up on the AK exam once every 2 years on a free response. There was a year recently where you're given a piecewise function. and it looked like that. It says calculate the average rate of change, so you did the slope formula, right? For EV point. Does the mean value theorem apply?
No.
Why not?
It's all wonky. It's all wonky.
All you have to say is f of x is not differentiable at x equals 2.
So does any point?
Therefore, the mean value theorem does not apply.
So does any point?
Any. It has to be completely differentiable on the entire interval. Okay? So,
Maybe you can tell me what's the pressure.
so there's an abbreviated statement that you can make. F is not differentiable at x equals 2, which implies that the mean value theorem does not apply.
Oh, this is the W. It's
It's the marker. What? Well, you'd be given 2 points.
Yeah.
So, yeah, sometimes you'd be given like negative 1, 1, and 5, 0, or whatever that is. I don't know. Calculate the average rate of change, and you do the math, right?
Yeah, you just plug this in.
And then it would say, does the mean value theorem apply? No, it doesn't. All right, let's do a problem.
I always have to go. Like, fill up the like completely, and then there's one more completely.
Oh, come on. M, V, T.
With?
I was just about to write that.
With.
It's just
Not ebonics class, it's mathematics.
There's a long time. You have to learn how to that turkey was your He probably ate some
I did eat some romaine lettuce.
Did you really? Are you okay?
Are you gonna die?
Okay.
We
I
had some.
destroyed that salmonella.
We had some, and we had to throw away like everything. Because my grandma was like super.
So it's my wife.
And you
I'm a rebel.
imagine if you would have turned up. You probably look like Brad.
I told you. Fixing it wrong. All right, so quickly, when you see mean value theorem, you think, okay, is f continuous? Okay, the square root of x on this interval, is that continuous? And those are all positive numbers, so the root x works. Okay, how about differentiable?
It should be.
Yeah, no negatives again, so we should be okay, right?
Yeah.
Okay, so always check those. And then you're thinking, okay, the mean value theorem means average equals instantaneous rate of change. And you just calculate both of those and solve the equation. So what's the average rate of change on that interval? It's a slope formula. F at 9 minus F at 1 over 9 minus 1.
Yeah.
Yeah?
Yep.
What's F at 9? 3, F at 1. Correct me if I'm wrong. Good?
Yep.
Okay, so there's your average rate of change.
Okay.
Okay, how do I calculate instantaneous rate of change? Okay. We've already done this today, haven't we?
Yeah.
Right there.
Yep.
1 over 2.
2x.
Nice.
Kira, what's the next step?
I don't know.
Brooke? You want to try? That's your next step. What do I write down?
It does not matter.
Average rate of change
So 1/4
equals
1 over 2 for
instantaneous rate of change.
all brackets.
Okay, again, you just do this. Calculate each of them, set equal, now solve the equation. X equals not 2.
4.
How did you do that?
With my, I actually copied it.
Oh, 2 times. Yeah, 2 times 2 there.
As I said with my mind, no. Copied it from another student. Nice.
That's pretty much all.
Who uses their mind?
Pretty much. Okay, yeah, you can solve that if you need to. Or you can just think it through.
It's great, great, and a good one.
Okay, any questions?
I didn't see that. Kellen, some of the things you say just made me
You know what? You can do whatever you want.
Oh boy.
Oh boy.
Just be prepared to deal with the consequences.
Turn around, cover your eyes.
I could.
Really?
That would be negligence, and I'm probably not going to do that.
That would be.
Risk everything I've ever worked for.
Question mark? No, it's a P.
Is it a B or is it a B? Welcome back from break.
Didn't you miss us?
Actually, I didn't.
I know, I didn't miss you. Dang, I would. Hey, thanks. I miss you. You know I always.
Go over here and see.
I miss you when we're not, when we're like arm length. It's always Does that say
FR, so
Okay.
we've done all the multiple choice in AP section 2. You're into the free responses now. The next few weeks, you'll probably see a lot of gains in those if you do the work.
Okay.
Yeah. Well,
Where's the FR?
yeah, so AP2, there's a free response section. Be number 1.
What?
Get your notes and your memory cards. Make sure you're recording those
Why would I know that off the top of my head? Just 4 weeks.
darn
4 weeks.
survey that I put on Classroom.
4 weeks.
If you go through them a couple times, put it in there.
It's not.
'Cause I'm giving you a grade at random spots.
3 weeks and then.
It's not a spreadsheet.
Yeah. So let's see.
For me, it is.
As well, I have
But it is.
For you, it's a 4.
Friday's the first.
Good.
Saturday's the first. Saturday's the first. You said that too. You don't even think about it then.